Welcome to the future of AI, infrastructure to scale your generative AI apps to success, brought to you by Control Plane and Arhasi. I'm Taylor, I'm the Chief of Staff here at Control Plane, and I'll be moderating this webinar. And today we'll be discussing guiding principles for a secure AI foundation and showcase a real-life AI chatbot application developed by Arhasi. And remarkably, this chatbot was built in less than 24 hours and was trained to comply with security, governance, and compliance regulations within the same time frame. We'll also demonstrate how Control Plane accelerates engineers' journey to instant cloud-native maturity without the extensive time and financial investment. And by automating complex cloud infrastructure management, optimizing costs, and ensuring enterprise-grade reliability, security, and observability, Control Plane empowers engineering teams to focus on building innovative applications rather than the infrastructure plumbing. So that's what we'll be covering today. And now what I want to do is get started by introducing our experts. Hi, Chiru, would you like to introduce yourself to the audience?
Yeah, I'm Chiru Bhavansikar, Chief AI Officer of Arhasi. My experience stems from shaping AI applications for over 8 years, and with a total experience of cloud and data for over 15 years. I actually shaped AI practice and addressed AI solutions, some of the largest firms around the world at Deloitte, PwC, and also consulted for Google in shaping their AI strategy. At Arhasi, we are focused on bringing turnkey responsible AI platform and expertise so that we can give you rapid AI solutions that are inbuilt with security, governance, and compliance. That's our objective. If I have to summarize that, bring the right expertise for you and bring the right solutions and platform which has embedded responsible AI principles. So you don't have to worry about security, governance, and compliance.
Thank you, Chiru. And hi, Doron. Thanks for being here.
Hi, everyone. I'm Doron Grinstein, CEO of Control Plane. We started Control Plane to allow any engineer to focus on the functionality, not on the infrastructure. And for those of you that are new to the Control Plane platform, I'll give a brief demo at the tail end of this presentation, showing you just how easy it is to get applications deployed on the platform. And yeah, looking forward to it.
Amazing. Thank you. And Chiru, it would be great if you want to go ahead and kick things off for us. But just a preface for those of you who are here, we'll do a Q&A session at the end of this webinar. So if you want to ask any questions in the chat during this time frame, we'll be sure to answer those questions at the very end. And Chiru, I'll kick things off to you.
So I want to start with my personal experience talking to clients over the last year. I was talking to a client, especially last week, and asked them about what they have been doing in the AI journey. They told me that they developed like 25 use cases over the last year. My question to them was, what were those use cases? And they said they are doing a lot of things, building AI chatbots, intelligent design assistants, integration of AI and IT service management systems, analyzing financial statements with AI, all cool things. My next question to them was, how many of those 25 use cases are in production today? The response was just one. When I dug deeper into like what really prevented them from putting all 25 use cases into production, it became evident that they lack a secure AI foundation. What I want to discuss with you is about guiding principles that we believe are extremely important when you are embarking on an AI journey. Let's start with looking at the building blocks for how you actually build your AI applications. It all starts with having secure, reliable, elastic infrastructure. Then you complement that with the right platform that gives you the ability to do CI, CD, etc. Top of that, you need to have the right data in place. Now, this is where your AI journey begins, where you start shaping your AI models for your specific use case based on the data. Finally, you actually can deliver those AI models as applications to the end users. At Arhasi, we bring solutions through our rapid platform that caters to the top 3 building blocks: AI applications, AI models, and data. While Control Plane provides elastic capabilities and end-to-end capabilities on the platform and the infrastructure side to support GenAI applications. So what are the 5 guiding principles from our experience? It's all about increasing productivity, being readily compliant in terms of PCI, SOC2, NIST, OWASP, Atlas MITRE, ISO, etc., etc. Having clear view of transparency and security by design, and be able to actually manage on an ongoing basis with the ease. These are the 5 guiding principles that resonate well and especially you want to consider when you are actually setting up into an AI journey. These principles are applicable at each building block. However, how they translate at each building block are different. Let's take transparency. At a platform level, transparency is about how the microservices or applications are talking to each other and capturing the right logs. While the transparency means at the AI model level is about how your model is actually making decisions for a specific request using the data. That's the difference in how the same principle translates at each building block. What we do at Arhasi is we developed this rapid platform, which stands for Rapid AI Productionization and Integrity Defense, RAPID, on Control Plane. It gives an instant, secure AI foundation. It caters to the needs of the design principles that are important for an AI foundation. Let's start with productivity. We improve productivity through AI augmentation using our chat module. That's basically a tailored Microsoft Teams module. That probably everyone is familiar with. What we did is we took Microsoft Teams and turned that into a secure and an intelligent chatbot with quick integration with your internal systems. From a security standpoint, we created NVIDIA-based security engine that plugs into AI modules and continuously looks for malicious code attempts, phishing, prompt injection, and sensitive data protection. We provide compliance through our assessment and testing suite. How do you comply with US White House executive order? How do you comply with European AI Act? How do you comply with safe frameworks? Whatever you build, does it stack up to the safety, trustworthiness, and performance? All these things you can measure, assess, and test using our rapid platform. We provide inherent transparency through our governance. We create observability. We showcase to you how a specific GenAI model is making decisions so that I can mitigate hallucinations and bias. We provide capability to manage drifts in its performance. I was talking to a client and he basically said that he put an AI model into production. It was performing well for 6 months and suddenly drifted in its performance and quality. And until their client told them that there is a problem with their AI system, they didn't realize that. We don't want our customers to be in that position. That's why we help them better detect and manage drifts in quality and performance. We aim to simplify operations by providing search capabilities on your corporate data natively out of the box from the platform. We provide integration modules into your backend systems from LLMs into ERP, CRM, ITSM, and HSM systems. We support every model in the world. We work with Google Gemini, we work with ChatGPT, and we work with Mistral, and that's fully available on Control Plane. What does it mean to you? From a traditional standpoint, if you look at the journey, AI initiatives get kicked off in a best case scenario. If everything goes perfectly well, organizations stand up an AI foundation, and that to MVP. That's about best case 12-week scenario. From there, another 12 weeks later, in a best case scenario, the first pilot use case gets MVP'd. How do we do that with our rapid platform on Control Plane? How we do that with Arhasi is AI initiative kicks off. In less than 4 weeks, you have a secure, governed, and compliant AI foundation on Control Plane. And you'll be able to go to production with our modules, or you can release an MVP of the use case in an additional 4 weeks. That is, in 8 weeks, you already showcased value of your use case along with a secure, scalable foundation. That's reduction of overall time by 1/3. That's significant. What I'm going to show you is how we used our platform to create a secure AI chatbot to do 2 things. And we did this in less than 24 hours because of the rapid iterations and the facility that's provided by Control Plane. How we did that is the first use case that I'm going to show you is using AI to manage IT service tickets. And the second use case is using AI to expedite the development process in GenAI development, which is training LLM models through prompt engineering. So what you see here is a simple chatbot, AI chatbot that we developed. This will help you manage IT service tickets with your backend system. All we do is, this is only for the demo purpose. We are choosing a model. In this case, I'm choosing a Vertex AI model. In a real world scenario, it is automatically chosen for you. We'll disable any security guardrails for the purpose of the demo. And we are initiating the model with the chatbot. Once the model is initiated, here we are going to ask, create a ticket. The model is asking for what is the issue with what ticket you want to raise. I'm going to say major downtime of servers. And the model is asking, what is your email? In a real world scenario, we can get this from Active Directory based on the person who is logged in. And the model is asking, what can you describe the problem further? Going to say that here, Oracle servers are down since this morning. The ticket is created. If I go here and refresh my fresh service, and this can be service now as well, you will see here a new ticket got created just now. Reported a few seconds ago. Oracle servers are down since this morning. You can take this further. Some of these level 1 tickets is something you can use AI to automatically resolve and close those tickets. And if they don't get closed, you can actually route it through a human in the loop, bypassing the AI. And these things can be implemented. The second use case I'm going to show you is a prompt fabricator. One of the most challenging aspects of AI development is shaping the right prompts. There are industry standards around how prompts can be shaped. We took those standards and turned them into templates. And we created like a trained AI model that asks for the prompt that you want to design, and it applies the right template. And then it basically creates a fabricated prompt that's more effective in your training. I'm going to log into this system to communicate with my bot. Once the bot is ready, I'm going to ask, who are you? It's going to tell, I'm Arhasi, a thought leader in AI security and governance. And here I'm going to say that I want to fabricate a prompt. It's going to ask me and also give me some choices. Here are the top prompts, templates, which template you want to pick. I want to pick STAR, which really means situation, task, action, and result. And here is going to ask me what prompt you want to fabricate. I'm going to say, I am a data analyst. I want to analyze financial statements. Now the model is going to take this prompt and reshape it using like STAR template and creates a fabricated prompt. And this is a prompt that I could use during my development to make my LLM more effective and train that my LLM. It's asking, do you want to fabricate more prompts? No, thank you. And now it's giving me an option. Do you want us to recommend the best prompt templates? What it really means is that depending on your use case and depending on your prompt, a different templates works better with the model. There are some prompts, depending on the use case and the template can be chosen. And also like the kind of LLM you're going to use also plays a factor in that. So we have like an advanced version of this, which basically where it will take your prompt, it automatically applies each prompt template, looks at the model that you're using and tells you which are the best templates that you want to use for your prompt. I'm going to say no. And there ends our demo. What we really wanted to show is with the rapid platform, Arhasi's rapid platform on control plane, we can shape these use cases really fast. We build these two in less than 24 hours. And the benefit that we see as a user of control plane is how rapidly we are able to iterate on the platform and the infrastructure level to build our GenAI applications.
Thanks, Chiru. Taylor? Thank you for the slide. So what Chiru was alluding to is that in addition to having the raw compute power, you need sometimes help in forging an application, an AI-based application that is compliant and intelligent. And Arhasi can help with putting all the governance and know-how in stitching together an intelligent AI-based application comprised of agents and things of that nature. I'm going to talk now about the raw control plane platform. And why would somebody want to use control plane? First, it gives you the freedom to run compute absolutely anywhere, whether it's on premises or any one of the clouds or even all of the clouds. Control plane has this notion of the global virtual cloud, which is like a VPC, but globally such that the VPC can stretch across multiple locations of a single cloud or multiple clouds and on-prem. So that's the first principle here. You got freedom. You're no longer locked into a particular cloud. Second, it reduces the cloud compute cost by at least 60%. And the way it does that is by not charging you for the NAT gateways, load balancers, Kubernetes brain nodes, Kubernetes worker nodes, all the observability tools that you typically pay for. Instead, control plane optimizes the compute such that you pay just for the CPU or GPU that you're actually consuming. Third, we have a patented technology called Universal Cloud Identity. It's the only one of its kind in the world, allowing a single workload to mix and match any one of the backing services of the hyperscalers. Control plane is the only platform allowing a single workload to mix and match BigQuery from Google, Cosmos DB from Azure, RDS and DynamoDB from Amazon as an example. You can now stitch together any one of the services of the hyperscalers, regardless of where the application executes. It can run on Hetzner, Linode, on-prem, in a Raspberry Pi. It doesn't matter. So Sun Microsystems many years ago coined the term write once, run anywhere. Control plane has achieved that vision, but not just with Java, but with any language. You can write a Go app, a Rust app, run it anywhere, yet still consume the union of all the services of all the clouds combined. So that's the third, the flexibility to mix and match. Fourth, it really reduces the cognitive load on engineers, allowing them to focus on the functionality, not on all the infrastructure goo. So the DevOps bag of tools is comprised of many, many tools: Kubernetes, Istio, Grafana, Prometheus, Vault, FluentBit, Knative, and the list is long and ever expanding. Control plane removes that nonsense, allowing engineers to get instant cloud native maturity and focusing on the code at hand. So that is the why. Now I'm going to show you control plane in action. So I'm going to share my screen. And I'll jump right into the control plane console. Everything you can do in the console, you can do programmatically using CLI, API, Terraform, Pulumi, and a few other interfaces. I'm going to go and create a global virtual cloud. I'll call it Webinar QA. And the Webinar QA is going to be comprised of certain locations. I can choose all the locations I've enabled for my org. These locations can be provided by control plane or provided by customers or a combination thereof. Or I can choose just one location or two locations, like I can do Amazon in Frankfurt, I can do Amazon in US East, Amazon in US West, but I'm not limited to Amazon. I can run it on Azure, I can run it on Google, or I can run it in other locations that I add to the control plane panel. And instantly, I get this global virtual cloud. Think of it as a VPC that spans across these regions. Anything I now deploy is going to run concurrently in these regions. And you may ask, why am I running in more than one location? The answer is availability and reduced latency. By availability, we mean if Frankfurt went down, we still want to get service, and that's what you get. You automatically get routed to the nearest healthy location. From a latency perspective, a person in the East Coast will get routed to the East Coast, and if that Amazon region went down on the East Coast, they'll automatically get routed to GCP, to Google Cloud Platform on the East, etc. Now, how easy is it to deploy an application? It's as easy as saying, let's create an app, call it a webinar video game, and I'll give it a container image from any image repository. We provide one at no cost. I have one on Docker Hub called Doron Mario. I'll make it public and deploy. And what I get is near instantly a TLS terminated endpoint, which I can easily put on a custom domain or many domains. Here it's just a weird looking domain because I didn't create like a special domain like webinar.com or something like that. In a moment, it will turn from not ready to ready once at least one of the locations have been has been stood up. And I can see it's ready because here in Europe, I can see it's ready and I have a specific endpoint for Europe. Now I can navigate to this URL, but I can also navigate to the global endpoint, and the global endpoint will factor in the geo routing. It will route me to the nearest healthy location to me. So I'm going to go to the global endpoint or canonical endpoint, click it, and I will be, we'll give it another second. So sometimes it takes, another couple seconds. And here we go. So it takes about 20 seconds to go. So here I am playing my application, or, this is obviously a very simple application, but if you have more complex applications like the one I'm going to show you, it is absolutely trivial. And you get logging, metrics, tracing, secrets management, service discovery, mutual TLS between services, a service mesh. So a lot of power, but we have a very short amount of time, so I'm not going to get into all of this. Of course, if you want to see more, contact us and we'll give you a full demo. But I can switch an org to an org called, let me see, these are my orgs. I have my demo org. I deployed in my demo org an application called My Olama. That's the name I gave it. I did a demo for a person named Lisa. And so I registered a domain called Lisa GPT. And if I look at the workload, I configured it with one NVIDIA T4 GPU, and I gave it a volume set. So I connected it to a persistent volume. And that application, you can see the domain name is Lisa GPT. I bought a domain for 99 cents on Namecheap. I can go to my Postman and I can say how many people are in Alaska. And I never asked that question. And it's not going to ChatGPT or anything. It's going to that model that is running on control plane. And according to this one, there are 731,000 people in Alaska. You can ask it any question you want, like how to make cheesecake, and it will go into that ball of yarn that is the Mistral model. But you can run any model whatsoever. And because I set streaming to false, it's writing the response, but it's going to show it to me when it's all ready. So making cheesecake at home can seem daunting, but with the right da-da-da, and it gives you the ingredients. Bottom line, it took me absolutely no time to host that container called, let's see what it's called. I forgot. Olama. So I can run Olama in seconds on control plane, and then Olama is the loader where I can use Llama 2 and Mistral and Mixtral and many other types of models I can run on control plane. Now, what we're introducing very soon is the ability to have a control plane endpoint for any model that you can imagine, including the commercial models like Cohere and OpenAI and Grok and open source models. So you'll have one-stop shop where you can say, here is the model, here's the query, give me my answer. And you'll be able to do embeddings, you'll be able to do your own data connections, you'll be able to do your own vector databases. And bottom line, we reduce the cognitive load, the cost, and the time to market, allowing you to focus on unique functionality and not be mired in infrastructure goo. That is the power of this control plane platform. And with that, I think we have a little bit more time. I can show a bit more on the control plane side. Taylor, how are we on time?
You're good. You can use the next 5 minutes or so, if you'd like.
Okay, sounds good. So when I deploy an application, I'll make a folder called webinar. I can create an application in any language whatsoever, and I don't need to know much about containerized applications. I'll just scaffold up an application, and I'll say here, hello, my webinar friends. And if I wanted to deploy this application, Control Plane provides a CLI called CPLN, where I can say image build, I can give it a name and a version, and say push it into the private image repository made available at no cost by Control Plane. And with or without a Docker file, it will containerize the application and push it into the private image repository or image registry you get with Control Plane. And once you have that image in the registry, in our case, webinar, we can deploy it from the command line, from Terraform, or from the UI. I'll just do it from the UI. By the way, of course, we support dark mode. Let's go create here our webinar app. For the image, we'll use Control-I for images and start typing webinar. And you can see here's the webinar coming in from the Control Plane registry. I'll simply run it, and I forgot to enable inbound requests, so it reminds me, and I'm done. So you can see the cognitive load, again, on the engineer, going from the code into a running system, in our case, running in 6 or 5 locations, was trivial. Now, everything that I can do, using the UI, I can view, for example, as YAML, as JSON, or as Terraform. So I have infrastructure as code. I can persist this into Git, and 9 months from now or 2 years from now, if I want to recreate it, I don't have to remember what I clicked. It's all codified. It's all as code. So, or if I made any changes, it's all subject to tamper-proof audit trail. So if I look at my application, I can see it's already ready, and I can see where it's ready. For example, in EU, it's ready. In US West, it's ready, and everywhere else. And if I wanted to just navigate to the application, I just navigate to it, and it's there. And that was the day 1 operation. The day 2 operation is looking at the logs and the metrics and the tracing and so on. So I can go to the logs. I like the logs in dark mode, and I like some other things in light mode. So it's just my quirkiness. And here I can see, I can choose the specific container, and I can see my request received coming in from Amazon US West 2, because I'm on the West Coast. And the reason I see request received is in my code on line number 9, I emit to standard output request received. Nothing in the code is specific to Control Plane, yet Control Plane is giving you all the observability you need without breaking the bank, paying very expensive observability bills. It's all included. Same goes for the metrics, same goes for the tracing. So I can go to the metrics. Even though we've just deployed, we're not going to see a lot of data, but we can zoom into the time series and see what we have. So I'll zoom in here. I'll choose all the locations in which I deployed to, and I can see how much CPU was leveraged in each location, how much memory was used in each location, etc. I can easily collect custom metrics, and I can also configure alerts to be notified via Teams, PagerDuty, email, Slack, and other channels when certain thresholds are exceeded or fall below. Bottom line, Control Plane gives you an unbreakable compute substrate stretching over any physical or virtual compute infrastructure, reducing the cognitive load on engineers while reducing the cost by a very, very significant measure. I'll show you an example. When I deployed my webinar video game, I configured by default capacity AI to be on, and that's a unique capability to Control Plane. When capacity AI is on, when we look at our deployments, we can see the system automatically allocated 25 millicores or 25 1,000th of a core and 32 megabytes of RAM. If we plug these ridiculous measures into the control plane pricing calculator, 25 millicores and 32 megs of RAM, customers are paying us by the second. So this is how much they pay by the second. If it's by the day, which is 24-hour day, it's less than 6 cents per location per day. A full month is about $1.75. Keep in mind that customers do not pay for any of these things, and NAT gateway alone is $100 a month that you do not pay for. You don't pay for the load balancers, you don't pay for TLS certificates, you don't pay for brain nodes. So rather than paying for 730 hours a month for nodes that are pretty much hitting the atmosphere, you're paying pennies on the dollar, but getting the cloud native maturity of a company like Netflix, but without breaking the bank and without accumulating the technical debt associated with maintaining a proprietary stack stitched up of Kubernetes and Istio and all the things I've mentioned earlier. So we wanted to give customers an unbreakable platform, and that platform would be consistent no matter what the underlying infrastructure is, stitching together all the capabilities of all the clouds. So if you have a Kubernetes cluster already on Amazon, on Google, on Azure, or elsewhere, go and run our pricing comparison calculator. It's an open source project. You can inspect the code. When you go to the GitHub repo, it gives you a very simple instruction on how to install it. So just do this. And after you run it, just run the control plane Kubernetes cost analyzer, and it should give you a report exactly how much you're paying now and how much you're going to save on control plane. If you're running into any issues, give us a call. We'll help you configure it. But you can look at the code, and it's very straightforward. You'll see that you'll save between 60 and 80% on your cloud compute, not to mention what it will do to your time to market and the labor cost associated with maintaining the infrastructure. So hopefully this was a good overview of control plane. I would love to open it up to questions. Do we have questions, Taylor?
And before we even get started with the Q&A session, we do have some questions in the chat, which is great. I just want to take a moment, though, to thank you both for providing a high-level demonstration of your solutions. And what I want to just mention to everyone who's still here today, I mean, Arhasi and Control Plane together do offer tremendous value for GenAI builders looking to focus on their innovative applications rather than waste time on the infrastructure plumbing. So hopefully everyone that was here today was able to see that. And the reason for why we formed this partnership between Arhasi and Control Plane is because Arhasi clearly empowers developers to construct GenAI apps that adhere to security, governance, and compliance regulations, while Control Plane has enabled them to attain that instant cloud-native maturity without reinventing the wheel, as Doron just showed. So with that being said, let's go ahead and open up the Q&A session, and I'll leave it to the both of you to answer. All right, I'm just going through the chat here.
Yeah, so let me see. I'll try to get the first 1 second.
Looks like Brent Foster was the first to ask a question. So he, Chiru, this is directed to you. You mentioned that Mistral is already available on Control Plane. Is there a specific container in the registry to reference with Mistral loaded up? Which version?
That's a question for me.
Okay.
So we will, you can run Mistral, or you can run, what did we call it? The Open LLM, you can run, we are, as I've mentioned, in a few weeks, about to introduce any model, Today, when you want to run the model, it's a very simple, straightforward process. You can shoot me, Doron, at control plane and node, and I'll give you the container image. Or I can send you the YAML. All you have to do is say cpln apply -f the YAML, and it will run for you. So it can run privately for you, or in a few weeks you'll be able to just obtain an API key and just run any model, not just Mistral. But if you want to run Mistral, shoot me a note and I'll show you how to do it in 2 minutes.
Great. And then we have Stephen Blystone who asked where he can find more information about this coming soon feature of having control plane endpoints for any model, vector databases, etc. Any ETA for when this will be released?
Yeah, it's in the 6-week horizon, so it will be announced and it will be heavily marketed and fully documented. So it's in the 6-week horizon, but if you need a preview or you need like an early version of it, just ping us.
And we have Adam who asked, what kind of resources do you need to run one of these models? I imagine it won't be cheap.
It will be a lot cheaper than what is available in market today. When you want to run your own model, you need to spin up a GPU, and depending on the size and the number of parameters in the model, it will be, yeah, it's not cheap, but a lot cheaper than what's available. But we're working hard on making this as affordable as humanly possible.
We have Moses who asked, how do you address data privacy as people tend to share sensitive data on chatbots?
Yeah, that's a question for me, and I will address that. With the rapid secure engine that we have, we address it twofold. One is, how do you train your model with the data? So we actually establish guardrails and controls on the data that the model consumes. The second is, what if that the model bypasses that and somehow happens to give away like a PII or a PHI information accidentally because there is some kind of a prompt injection or malicious code attack or phishing or something happens. Even on that, we actually establish security guardrails and out of the box that would help us to continuously monitor the model and how it's the inputs that are coming into the model and the outputs that the model is actually providing. And we'll basically able to apply a layer of guardrails on top of that. You can imagine that it's like a firewall for LLMs, that we established that. There was also another question about vector databases. Like we actually have like vector database on the Rapid platform. So we extensively use that and it's deployed on control plane and it has got the endpoints. If anyone wants to use like a vector database, like, yeah, we can actually give the endpoints to you guys.
Amazing, thanks, Chiru. We have Sean who asked, it seems like a higher level of abstraction rather than looking at a 747 cockpit with hundreds of services to configure correctly.
It's not a question, it's just a note, it's just a comment.
Okay, I don't know if you wanted to elaborate on that.
Yeah, it's a lot easier to fly a control plane than to fly a 747.
And then we got Stephen who asked, what would the pricing be for the workloads with NVIDIA GPUs? I don't see any mention of that on the control plane pricing page.
Yeah, the NVIDIA GPUs, currently we support T4 and A100s, and we have a minimum amount of CPU and RAM that you need to allocate, and you basically are paying for the CPU and RAM. We are working on making many more GPU types available to you, and you will add very soon in the next couple weeks all the pricing to the pricing page. If you've noticed, for those of you who are using control plane, we've added a bunch of stuff to the pricing page, like bring your own compute and also persistent storage and custom load balancers and stuff like that. We're adding GPU and other accelerated computing capabilities to the pricing page soon.
We also have a question in regards to how control plane makes money.
Great question. We make money by buying a lot of compute and selling it. And the way we do it, think of you want to rent a 400 square foot office space. And you go downtown, they tell you on the 10th floor, we have 12,000 square feet. It's $1 a square foot. You go $12,000 a month. That's a lot. I just need 400 square foot. They go, sir, it's $1 a square foot times 12,000 square feet. And that's too much. You come to control plane, we charge you $2 a square foot, but we say, how many square foot do you need? 400. We do the math and it's $800. We just saved you $11,200 on the space that you needed. You're happy because you're paying $800. It's affordable. We're happy because our margin is high, and the landlord is happy because we just purchased 12,000 square feet that we're selling to company A, B, C, D, E. That's the high level, how we make money on the compute that you purchase from us. If you bring your own compute, we charge you for the storage, for the metrics, the logging, and the tracing, if you want to use us for that. The other way we make money is we charge you retail $5 per CPU for the compute, for the management. And these are the two ways we make money, and we make it up in volume.
Amazing. So I think we just about answered everyone's questions here. We just got a question about if there's going to be a recording for this webinar. There absolutely will be a recording. So I'll make sure for those who had to drop off or miss this webinar, apparently a lot of people thought it was going to be live on LinkedIn, which is why we didn't get as many attendees as we had registered. So yes, absolutely, there will be a recording that we'll go ahead and blast out to everyone who did register as well. And I just actually shared our poll number 2 with any topics you would like to see covered in any upcoming webinars that we do moving forward. And so after getting all these results, we'll share in an email with all of you guys what we currently have in store for the future.
Great. And do not be shy. If you need help with AI applications, talk to Chiru. And if you need help with the infrastructure, you know where to find us, hopefully. And we're eager to help you in any way we can. And we're very easy to deal with, hopefully.
All right. Thanks, everyone.
Thank you, guys.
Thank you, everybody.
Hope you
Bye-bye.
enjoyed it.